In this video, we're going to go over derivatives, finding the derivative of the function using a power rule. We're going to go over examples with polynomials, square root functions, rational functions, absolute value of x, things like that. So let's begin. According to the power rule function, the derivative of x raised to some power is equal to that power times x raised to the power minus 1. So for example, the derivative of x cubed is going to be 3x squared. Take the 3, move it to the front, and then subtract the 3 by 1, you'll get 2. So what is the derivative of x to the 4th power? The derivative of x to the 4th is 4x cubed. The derivative of x to the 5th is 5x to the 4th. The derivative of x to the 6th is 6x to the 5th power. For x to the 7, it's 7x to the 6th power. Now what about the derivative of 4x cubed? What's the answer? So we have to use the constant multiple rule. Don't worry about the 4. Differentiate x cubed. The derivative of x cubed is 3x squared. And then multiply by 4. So the final answer is 12x squared. Let's try another one. What is the derivative of 5x to the 6th power? So the derivative of x to the 6th is going to be 6x to the 5th power. So 6 times 5 is 30. So the final answer is 30x to the 5th. Now what about 7x to the 8? The derivative of x to the 8 is 8x to the 7th power. 8 times 7 is 56, so the final answer is 56x to the 7th power. Let's try one more example. Try this one. What's the derivative of 8x to the 5th power? So differentiate just this part, x to the 5th, which is 5x to the 4th. So 5 times 8, that's 40. So it's 40x to the 4th power. What is the derivative of 5x? The derivative of 5x is 5. The derivative of 3x is 3. The derivative of negative 4x is negative 4. For pi x is simply pi, and for e times x, it's e. E and pi are constants. Now let's see why that's the case. Let's say if we want to find the derivative of 5x. This is 5x to the 1st power. So using the power rule, it's going to be 1x to the 0 power. Anything raised to the 0 power is 1, so this is simply 5 times 1, which is 5. Now, what is the derivative of a constant? So what is the derivative of 7? The derivative of any constant is 0. So the derivative of negative 9 is 0. The derivative of pi, that's a constant without an x, that's 0. The derivative of e without the x is 0. So using the power rule, you can view it this way. 7 is the same as 7x to the 0, since x to the 0 is 1. Now if you take the 0 and you move it to the front, it's going to be 7 times 0x to the negative 1. 0 times anything is 0, so the whole thing is going to be 0. So that technique could remind you that the derivative of a constant is 0. Now let's say if we have many terms. Let's say f of x is equal to x cubed plus 6x minus 8. Go ahead and find the first derivative of this function. So let's differentiate every term separately. What is the derivative of x cubed? The derivative of x cubed is 3x squared. The derivative of 6x is 6. And the derivative of a constant is 0. So the first derivative is 3x squared plus 6x. Now what about the second derivative? What is that equal to? So the 6, which is a constant, will turn into 0. To differentiate 3x squared is going to be 3 times 2x. 2x is the derivative of x squared, so the second derivative is 6x. The third derivative, the derivative of 6x, that's simply 6. And the fourth derivative, that's, since this is a constant, the fourth derivative is 0. Let's try another example. Let's say f of x is equal to 4x to the fifth power minus 7x cubed plus 8x plus 4. So the first derivative is going to be 4 times 5x to the fourth. And then 7x cubed, that's going to be 7 times 3x squared. The derivative of 8x is simply 8, and for the constant is 0. So this is equal to 20x to the fourth minus 21x squared plus 8. And you know how to find the second and third derivative if you need to. By the way, if you want a complete review of derivatives, starting with the power rule, product rule, quotient rule, chain rule, derivatives of trig functions like sine, cosine, natural logs, exponential functions, inverse functions, implicit differentiation, finding derivatives using limits, check out my video entitled Derivatives, Power, Product, Quotient, and Chain Rule. If you do a YouTube search, you should find it. And then you can get an entire review on derivatives. So let's continue with this video. Now, how can we find the derivative for the function 1 over x? What's the answer? For this one, you want to rewrite it. You want to move the x from the bottom to the top. If you move x to the numerator, the 1 is going to become negative 1. That's a rule of exponents. Whenever you move the x from the bottom to the top or from the top to the bottom, the exponent of that variable changes sign. So now we can use the power rule. So let's move the negative 1 to the front. So it's going to be negative 1x, and let's subtract this number by 1. Negative 1 minus 1 is negative 2. Now let's rewrite it. Let's take the variable and let's move it back to the bottom. So it's going to be negative 1 over x. The negative 2 is going to become positive 2. So it's negative 1 over x squared. And that is the derivative for 1 over x. Let's try another example. Let's say f of x is 1 divided by x squared. Feel free to pause the video and see if you can find the answer. Go ahead and find the derivative of that function. So the first thing that we need to do is we need to rewrite it as x to the negative 2. Now let's use the power rule. Let's move the exponent to the front. So the derivative is going to be negative 2x to the minus 3. Don't forget to subtract this by 1. Now once we have this answer, let's rewrite it. Sometimes you can leave your answer like this, but if your teacher wants you to simplify it, if they want you to get rid of the negative exponent, you can write your final answer like this. So when you move x back to the bottom, and don't forget to change the negative 3 to a positive 3. So this is the final answer. Here's another example for you. Let's say if f of x is equal to the square root of x. What is f prime of x? What is the derivative of that function? So this is x to the first power, and there's an index of 2. So the square root of x is the same as x to the 1/2. So you want to rewrite it first. Now we could find the first derivative. So using the power rule, let's take the 1/2, let's move it to the front. So it's going to be 1/2 x. Now we need to subtract the half by 1. So what is 1/2 minus 1? To subtract them, we can get common denominators. Negative 1 is the same as negative 2 divided by 2. So now that the denominator of the two fractions are the same, we can subtract 1 and 2. So 1 minus 2 is negative 1. So this is negative 1/2. So that's the first derivative, but we can rewrite it. So we can bring the x to the bottom, so it's going to be 1 over 2x to the positive 1/2. Don't forget to change the sign. Now, if we want to, we can convert x to the 1/2 to a radical. X to the 1/2 is the same as the square root of x. Typically, you can leave your answer in this form or in this form. Now, if you want to rationalize it, you can multiply top and bottom by radical x. The square root of x times the square root of x is the square root of x squared, which is x. So you can leave the answer like this as well. But this is the most common form of the answer. Now, what about this one? What is the derivative of the cube root of x to the 5th power? Try that example. So just like the other example, we need to rewrite it as x to the 5/3. So now we could find the first derivative. Let's take the 5/3, let's move it to the front, and then let's subtract it by 1. So it's going to be 5/3x, and then 5/3 minus 1 is the same as 5/3 minus 3/3. 5 minus 3 is 2, so this is going to be positive 2/3. Now, since the exponent is positive, we don't need to move it to the bottom, so to speak. We can leave it the way it is. Or we can rewrite the answer as 5/3 cube root x squared. So we can leave the answer like that if we want to. Try this one. Let's say if you have the function 1 divided by the square root of x. Go ahead and find the derivative. So let's rewrite it. We know the square root of x is x to the 1/2. And we need to move x to the top. So if we move it to the numerator, it's going to be x raised to the negative 1/2. So to find the first derivative, let's take the negative 1/2, let's move it to the front. So it's negative 1/2 x, and then negative 1/2 minus 1, or minus 2/2. Negative 1 minus 2 is negative 3. So this is going to be negative 3/2. So this is the first derivative, but let's simplify it. Let's rewrite it. Let's move the x back to the bottom because we have a negative exponent. So negative 1, the 2 is in the bottom as well. So it's going to be 2x to the positive 3/2. At this point, we can turn it back to a radical. So we can say it's negative 1/2 square root x cubed. Now let's not worry about rationalizing it. So let's leave it like this. But if you want to rationalize it, here's what you can do. To rationalize the bottom, multiply. Well, first we got to simplify it before we rationalize it. The square root of x cubed can be rewritten as the square root of x squared times the square root of x to the first, because 2 plus 1 is 3. So we can break it down like that. Let's move that to the top. Now the square root of x squared is x. So now let's rationalize it. Let's multiply the top and bottom by radical x. So we can leave the answer like this: negative root x divided by 2x. Now radical x times radical x is the square root of x squared, which is just another x. And then x times x is x squared, so it's negative root x times 2x squared. Now some teachers may want you to simplify it fully. Other teachers, if you leave the answer like this, it's okay. So it really depends on your teacher and how far your teacher wants you to go. If you're dealing with an online assignment, typically you can leave your answer like this: negative 1x to the negative 3/2. If you put this in to your homework assignment, this should be fine. You don't have to simplify it all the way here. But it really depends on the class you're taking and how far you have to go. Some teachers will accept this as an answer on a test. But if they want you to fully simplify it, you may have to go all the way to this form. So find out what your teacher wants you to do. What would you do if you're given a problem that looks like this? 5x to the 4th plus 9x cubed divided by 2x squared. How would you find the derivative? Now, if you have a fraction where the denominator only has one term, separate it into two fractions. So this is equivalent to 5x to the 4th divided by 2x squared plus 9x cubed divided by 2x squared. And then simplify. So f of x is equivalent to 5 over 2, and then x to the 4th divided by x squared. You need to subtract the exponents. 4 minus 2 is 2. So this is 5 over 2 x squared. For the other one, it's 9 over 2 x to the first power. So now we could differentiate it. Let's rewrite the constant. The derivative of x squared is simply 2x. The derivative of x is just 1, so this becomes 9 over 2. 5 over 2 times 2x, the 2's cancel, and so you just get 5x. So the final answer is 5x plus 9 over 2. Now here's a question for you. Let's say if f of x is equal to the absolute value of x. What is the derivative of this function? Before we can find the derivative, you need to understand the absolute value function. The absolute value of x, if you graph it, it looks like this. So the right side is basically positive x. That's the graph of the right side. The left side is negative x. So let's say if the absolute value of x is equal to 4. Whenever you open the absolute value equation, you get two functions, positive x and negative x. So thus x could be 4 or negative 4. And it makes sense because the absolute value of 4 is 4, and the absolute value of negative 4 is 4. So the absolute value function can be broken up into positive x and negative x. So if you rewrite it as a piecewise function, it's positive x when x is greater than 0. It's negative x when x is less than 0. Now, the slope of the line. If you have the graph y equals x, what is the slope? The slope is 1. The derivative is going to give you the slope of the function. Since we have a straight line, we have a constant slope. So the slope is 1 on the right side, and the derivative of negative x is negative 1. Notice at 0, it's not differentiable. The slope changes instantaneously from negative 1 to 0. It doesn't change gradually. So even though the function is continuous at x equals 0, it is not differentiable at x equals 0. The derivative does not exist at x equals 0. If you plot it, it would look something like this. To the left of 0, it would be negative 1. To the right of 0, it would be positive 1. But at 0, we can't say what it is, so you could see for the f prime of x, if you plot it, we have a discontinuity at 0. So that's why it's not differentiable at x equals 0. Now, how can we write the derivative of the absolute value function? What can we submit as our answer? So f prime of x, we need to write it as a piecewise function as well. The derivative of positive x is positive 1, and the derivative of negative x is negative 1. So the first derivative is 1 when x is greater than 0, and it's negative 1 when x is less than 0. So that's how we can write the derivative of the absolute value function. Let's try another one. Now let's say if f of x is equal to the absolute value of 3x minus 12. What is the derivative of the function? So first, let's represent it as a piecewise function. If you graph it, how will the graph look like? To find a vertex, set the inside equal to 0. So if 3x is 12, if you divide by 3, 12 divided by 3 is 4. So it's going to shift 4 units to the right. The vertex is at x equals 4. Now the slope, which is the number in front of x, is 3. So it's going to rise with a slope of 3 to the right, and it also goes in the other direction with a slope of negative 3. If you go from left to right, it's decreasing. So that's the graph of the function. That's the general shape. So notice that it's not differentiable at 4. It's not differentiable at the vertex. So the right side of the graph is positive 3x minus 12. The left side of the graph, you need to multiply everything by negative 1. So instead of having positive 3x, it's negative 3x. And instead of negative 12, it's positive 12. So if this graph continues, it's going to touch the y-axis at 12. That's the y-intercept. So we can write the function as negative 3x plus 12 and 3x plus 12. So when x is greater than 4, it's positive 3x plus 12. Well, actually, I mean 3x minus 12. I forgot the negative sign. So that's when x is greater than 4. And when x is less than 4, we have the left side of the absolute value. It's negative 3x plus 12. So now let's go ahead and find the first derivative. So f prime of x is going to be equal to the derivative of negative 3x is negative 3. The derivative of 12 is 0. The derivative of 3x is 3, and the derivative of negative 12 is 0. So the derivative is negative 3 when x is less than 4, and it's 3 when x is greater than 4. So that's how you can find the derivative function of an absolute value function. So that is it for this video. Thanks for watching, and don't forget to check out my other video, derivatives, power, product, quotient, and chain rule.